Okay, and we're now recording to the cloud.
Okay, thank you. Sorry about that.
Okay.
All right, that's thanks so much for the intro, Charlotte. And just to, to clarify for the recording, we're on the water quality monitoring, oil and gas OpenHour. And thanks everybody for joining in. I think maybe at this moment we'll go through and do a quick round of intros. So let's, if we can, take a moment and say your name, where you're calling in from, and if you have like your most pressing concern or knowledge gap in this area of water quality monitoring for oil and gas. And I'll just go around in a circle based on who I'm seeing on my screen. And share those details. And I think we're also taking some notes on this as well. So my first person top left is actually Bronwyn, if you want to share first.
Oh, hi. Yeah, I'm Bronwyn. I'm one of the Public Lab staff members. I'm located in New York, where we've got a lot of oil and gas in our water. So yeah, I mean, I think my pressing concern or interest is in people having what they need to be able to look into the water that they're living with. So I'm a jump in a canoe and stick something in the water kind of person. So I'm always interested in tools and techniques for kind of making sense of what you've got in a jar.
Okay, great. Actually see myself as second here, so I'll just go next. So my name is Stevie. I'm calling in from Hudson, New York today. And my my biggest knowledge gap in this area is how, like, I think I can figure out to narrow down if something is potentially oil, but I can't get anything beyond that. Like when we get false positives around the methods for using a blue-ray laser, like we can get false positive readings for oils, for like fish oil or a number of other things. I want to know how to get that next step to know whether or not something has water that has oil in it. So that's a knowledge gap that I'm interested in exploring more with people. I see Charlotte.
Hey, so I'm Charlotte. I'm from New Orleans. I'm actually from the Northeast, living in New Orleans right now. And I am most interested in how these issues tie into environmental justice and advocacy. So I'm kind of interested in what people have found is the most effective, like, scientific information to get about water in order to use it for advocacy.
Okay, great. And Will?
Hi, sorry, switching gears from taking notes. I am Will. I am one of the three fellows. I'm the hardware fellow. I'm calling in from Providence, Rhode Island, and I am my big kind of question is just about what sorts of, because I'm working on the hardware. It's just about what sorts of sensors and hardware and tools are most useful for kind of advocacy outcomes and other kinds of outcomes. So similar to what Charlotte said, with a bent on the tech and trying to figure out how the technology can be kind of driven by communities.
Thanks, Will. Jeff, are you available?
Yeah, I'm Jeff. I work at Public Lab, and I'm calling in from somewhere near Hartford, Connecticut, but I don't live there. And I guess I'm really interested in like colorimetric strips, and generally like how sensitive they are, or like what the many things there are that they can measure, and I'm wanting to build my knowledge on those. I haven't really used them much since I had an aquarium when I was a kid. So
Thanks, Jeff. Chris, are you available?
So I'm Chris. I'm an environmental attorney and chemical engineer. I'm in outside DC in Maryland, and my background's in chemical engineering, so I have a lot of analytical experience and worked in pharmaceutical labs. So I know sort of the non-public lab side of things, and I actually have a GC that I bought when I started my law practice, thinking I would go out and start taking samples. And so I've used sort of the high-tech tools, and I've been trying to work over the past 15 years to try and empower communities to do more, something between qualitative and quantitative testing of their own to document, things like oil and gas with respect to fracking, with respect to traditional oil and gas and other contaminants, and be able to correlate that with their own sensory experience as well as the health of their community, to try and tie those things together. So that's me.
Thank you, Chris. Liz.
Hi, I'm Liz Barry, normally in Brooklyn, but calling in from where Stevie is right now in Hudson, New York. And I'm really excited to hear what everyone presents tonight. Thank you.
Leslie, are you available?
Hey there. Everybody here. So let's see, I'm from Philadelphia. I have a history of showing up at barn raisings for public lab. Huge interest in hardware. I'm an Arduino geek, and I would say lately I've been getting into Google Earth Engine because I've been forced to for one of my remote sensing classes at school, and I'm in love. So I'm all about the sensors, whether they be hardware, chemical, or from above.
Thanks, Leslie. Matei. Oh, I think you're on mute.
Hey, can you hear me?
Yes.
Hi, hi, long time no see. So I'm Matei Vakula. I am in upstate New York in Troy right now. I was working with the oil testing kit and the spectrometer. I think it was like 2014 or 14, I believe. Yeah, I'm just wondering where are we at right now around all what is going on with the development of the tools and everything.
Thanks, Matei. Katie.
Hey, can you hear me?
Yes.
Yeah, I can hear me across the table. My name's Katie. This is Maggie. I am a longtime public lab participant. Have been out of it for a little while. I'm also a +1 on your hardware fellow. Yeah, and I'm just mostly here to listen, interested in what has been going on in oil and gas testing in the last year or so, and catching myself up.
Thanks, Katie. And I have a phone number calling in from a 504 number.
That was it me, Roland?
Hey, Roland. Yeah, so hey. Great. We're doing your name, where you're calling in from, and yeah, awesome.
Hey, I'm Roland Black. I'm from New Orleans. I'm just making it back from Chicago, so just trying to get things together. But yes, I'm new to public lab. I've only been with them for about 2 months now, and I've been very interested in learning the technology and the hardware. So I'm just here to listen and learn some new things.
Great, thanks, Roland. And I'll pass it back to Charlotte or Jeff, whoever would like to start and take over some facilitating.
Sure, I'd have to start it off, I guess, but definitely feel free to interrupt me at any time. We brainstormed some questions here, and I guess, just to sort of get conversation going, the first one was just what tools have you heard of or used for measuring levels of oil and gas contamination in water, and what metrics do they measure? Conveniently, that lines up with sort of one of my questions about like colorimetric strips, but just more broadly, like not just, electronic tools, but all different types of monitoring. Anyone want to kick it off? I'll offer one. pH is like one of the most basic things, maybe not, no pun intended. One of the most simple things to, sorry, it really wasn't intended, to measure, but I read recently, and this is sort of more on easy to do, not very rigorous end of things. Thanks. But I thought very interesting was like how red cabbage changes color in different pHs. And I read a tutorial online about how to make, pH sensitive paper by like blending a bunch of red cabbage and then dyeing paper with it. And I thought that was pretty interesting, actually.
Chris, I'm wondering what methods you're using in the communities that you're working with who are exploring some of these questions.
So the most recent, there's two examples of things that I've done recently. One is sort of more toward the high tech end, and one is more toward the what Jeff was just talking about. So one, I just visited a community out in Oregon, and I'm working with a law firm that has some money, so we rented a device called the Frog 5000. I don't know if you guys have seen it, but it's a $20,000, it's a portable GC, like a handheld GC, which I didn't know existed. I mean, I have a GC that's like a, quote unquote portable, but it's a big box that you put on a lab bench. And this was something that we could take out in the field and go into the neighborhood and run samples and get, not just get a ppm level of, flammable VOCs, but we could get, benzene versus naphthalene versus other things. So it was, again, toward the higher end and not something that you could equip everybody in the community with. But the flip side of that, or another example that's more publicly available, I was working with a community in Texas that has concerns about their drinking water, particularly, they're on city water, but the city switched from chlorine to chloramine. I don't know if anyone on the call has any experience with communities with chloramine. But anyway, basically they're using an aminated chlorine to disinfect the water. And what that does is it reduces the amount of regulated chlorine byproducts by increasing the amount of chloraminated chlorine byproducts that aren't regulated. So it just shifts the bad byproducts to something that's not being tested for and not being regulated. And so one of the things that we did with the community was we had people over the course of their chlorine burn, where they were dumping in additional chlorine to try and disinfect the entire distribution system, we had them get, pull strips. So, similar to Jeff's pH paper, and just do logs of their tap water and their showers, with pull strips to see how the chlorine levels changed over the course of this process of throwing a bunch of chlorine into the system and sort of doing this burn to try and disinfect. So, those are two examples at sort of either end of the spectrum where I've tried to use, sort of community empowered, techniques to gather some, either qualitative or quantitative data that we can use, not necessarily directly in a lawsuit, but for purposes of advocacy, and then ultimately, putting together a lawsuit and then doing some more rigorous testing with the lab and everything else.
I have a couple follow-up questions on that.
Hold it, can you just define GC first?
Sure. It's a gas chromatograph, so I don't know what people's backgrounds are, but a gas chromatograph is something that you would use to detect, either VOCs like benzene, toluene, oil and gas constituents, SVOCs like naphthalene. The plant that we were looking at in Oregon is a creosote plant. You can also find chlorinated compounds there as well, like PCBs, dioxins, things like that. So you might typically hear of something being a GCMS. So a GCMS is a GC with a mass spectrometer on the end of it that gives you a specific identity of a chemical, which is also $120,000 versus something like a $20,000 instrument that just separates and lets you identify based on peaks.
And did I hear, Charlotte, you had a question or something? Or was it
Yeah,
someone?
well, I had one question on just the tool rental. I'm wondering whether you rented from the manufacturer or from another partner, and if you have any thoughts about, you know, if a person or group wanted to, how would they access different higher tech tools?
Yeah. I mean, so we got a pretty good deal. I forget. There were two options. We got the more sensitive of the two. We rented from a third party distributor, I guess you would say, although it doesn't seem like there are a lot of people using these things. So when we were talking to the distributor, we were also talking to the manufacturer. But I'd be happy to share the place that we rented from, which I think was a pretty good deal. I think, you know, again, it's not cheap, but I think we paid somewhere between $500 and $1,000 for like maybe a week or a couple days. I think at least 2 or 3 days. And the beauty of this thing is you can put this thing, I mean, I don't know people's backgrounds and what, you know, not just backgrounds, but sort of what your communities are experiencing. But in Oregon, where we were, this creosote plant is crazy. I mean, we were in a park in the middle of the day across, you know, within a couple stones throw of this plant. And, you know, I stood there in the park, and I'm a believer, and I stood there thinking, it's not really that bad. I mean, the plant's over there. I don't smell anything. It's pretty nice weather, you know, no big deal. And we went back to the same park at 10 o'clock that night. And it was, I mean, you got out of the car and you smelled like you were in a blanket of mothballs. I mean, it was pure naphthalene. It was coming from that plant, no question. And, you know, and we went in, not to be dramatic, but this is, you know, why I think we do what we do. We went into this woman's house that we were going to meet, and she's got 3 kids, and she's a single mom, and she's dealing with, you know, on top of all the issues of life, she's being poisoned. And the beauty of the device is that we could put this thing in her living room, run a hose out the window, and then have this thing collect, you know, a GC, you know, someone asked, I mean, a GC it's not an instantaneous read. You have to separate the chemicals before you can identify them, but it runs for about a 10-minute cycle while it runs through the column and identifies each chemical. And so you can basically get real time every 10 minutes, run another sample through there, and you could put the thing in the living room, run the hose out the window, and start pulling samples for a 24-hour period and show what we've all heard communities talk about, which is, you know, it's when the sun goes down and the night shift comes in that they open up the fart valve and poison the community, right? And to me, getting something like this to the community, which I'm a you know, I love public lab and I love what they're doing, and I think the closer we can get to the quote unquote rigorous lab data, you know, the more leverage you're going to have, and the more freaked out these companies are going to be, because they and the state departments of health and departments of the environment will come out and patronize people and pretend like no one knows what they're talking about except for them, and, you know, dismiss any, oh, we smelled something and I got a headache and I got a nosebleed. And then they tell people, oh, that was, you know, that must have been your nail polish remover, you know, like, no. So to me, yeah, I mean, if you have a community that can pull together some donations to get one of these things, or you have a nonprofit locally that could pay for this, I think it's a tremendous tool to get into the community and to show that, you know, people aren't making things up when they talk about headaches and nosebleeds and, you know, what's happening at night versus the day when, you know, the regulators that are there might possibly be paying attention.
I think I saw Liz had a question, but maybe Charlotte had a question first, actually.
Well, there was one other thing. I think you just touched on it a lot too. I think with both the chloramine as well as this, I think you've talked a little bit about being strategic about when and where you're testing. So I think you talked a little bit for the Oregon testing, how you made those decisions. I'm wondering, like, how did you know about the changes that were going to be happening in the water treatment plant, and how did you organize around that? And do you have any general advice about how you learn that sort of information proactively?
So the good thing in the water treatment plant issues was a community in Texas, and they were, it's funny. I deal with a lot of communities where the moniker from, the patronizing name from the regulators and the departments of health and things is like, soccer moms. There's a bunch of soccer moms, right, with too much time on Google. And the group there, which was not really soccer moms, and most of them people with full-time jobs and everything else, but they had put together a lot. I mean, they really had self-educated and learned a lot. And so they had been filing FOIA requests. They had been sending in letters and getting, some actual useful information, such as when they were going to do the chlorine burn, for example. And then they started talking to me, and it was sort of the interaction between my background in I had done a case about chloramines in the past. And so I had some knowledge about how the water treatment process worked, and the fact that they had gotten sort of some of the base level facts that I could put together. Okay, this looks like the right timing. The other thing that your question sort of touched on, and maybe this is helpful or interesting. The Eugene case, the case out in Oregon that I went to look at, it was really a case. The funny thing, and one of my dogs is in the room with me. He's luckily, for you guys' sake, being quiet. But a woman had posted on Facebook about her two of her dogs getting the same cancer and dying within the same year. And all I did was posted a response, which I'm a guy that, when I hear about 2 dogs dying of cancer, the same type of cancer, to me, that doesn't sound right. And for better or worse, my response was, sorry for your loss, but you might want to check your water. Like, something might not be right. And, luckily she wasn't offended, and she wrote back and said, yeah, gee whiz, like, I agree, something must not be right. And with a short conversation with her, she says, well, we do, when I go out in the morning and walk my dogs, I smell this mothball smell. And, I know mothballs because I'm a chemical engineer, and I knew, that's naphthalene. And then she says creosote plant, or I might have looked on a map and just, Google Earthed it and saw, I don't know, somebody was talking about Google Earth, but looked on Google Earth, saw gee whiz creosote plant, that's naphthalene. Like, yeah, she's not making it up. This is what's going on. And so when we looked at what we needed to go out there and look for, naphthalene and pentachlorophenol, which is another wood treatment, part of creosote, basically were some of the things that we were looking at. And I guess the last thing I'll say about that, which nobody has talked about, and I'm, like I said, I love public labs. So, but another piece of data that we need to get tools to track is people's health data. And, there aren't, typically the state agencies and these people that are out to protect our, health and environment, they say, well, we can't share that because it's protected health information, and we don't want anyone to know whose neighbor's got cancer and whatever else. But the truth is that information, is what will empower communities, because you may not know that there are 6 people on your block that are suffering from some of the same symptoms that you are. But those things are important. And that's the way that that you start to recognize you're not the only one. It's not in your head. It's not just bad luck. It might be the fact that, at 10 at night, you're getting poisoned. And when you wake up with a bloody nose, that's the least thing to be concerned about. Right. So, tracking health information on top of and layering on top of these other environmental things, I think, is important.
Thank you. Liz, you had a question too.
If there's time for it, I was interested, Chris, in the language you used. After you took out the GC, you said that this could be used to push for more rigorous testing. And I was just wondering, who is pushed by the data that is still community collected?
Yeah, so I mean that's a good question, right? So in situations where I'm involved and where I have a money, which I don't always have, but sometimes I do, then I would be pushed, right? So I'm all about spending only good money, right, and doing it wisely. So where I can go out and do a sniff test and then a paper test and then rent a device test, and then I can see, okay, these are the things I'm looking for. Of the things I'm looking for, this is what I'm finding. And of that, now I can go and pay a lab to give me an EPA certified result that I can file a lawsuit over, or, you know, take the next step on. That's one of those that may be pushed. The other is the, you know, are the state health departments and the state environmental departments and the EPAs of our communities that need to be pushed, because they will, you know, they will dismiss anything and everything until you have the same, you know, certified lab analysis that they're looking at. And frankly, even when you have that, they'll tell you you didn't take the sample right because you're not trained and you're not a chemist and you're not this and you're not that, most of which is really irrelevant to the type of results that you're looking at, right? And so when you come in with these more quantitative results, you can, you know, I mean, pick the analogy, but you know, or the metaphor, like catching them with their pants down to say, okay, we are finding evidence of these things, and you need to go and test for these things, and not tell us it's just, you know, it's just the local farm or it's the local, you know, XYZ that they want to point the finger to as not being a threat to people's well-being or health, right? So I think you can use it, and you know, you can use it to take the next step. I forget, I think it was Charlotte talking about renting a device. Well, that's not the first step you necessarily want to do, because not every community's got $1,000 to spend on a device. But once you find out that, you know, here's the location, or these are the chemicals that you're looking for, you know, you want to narrow your I don't know where my hands are. You know, you want to narrow and focus your investigation and bring in, you know, sharper tools for those things that you've now identified. Because at the beginning of one of these community situations, you don't know what you're looking for necessarily. You know, you might have 10 things on your mind, and maybe even 10 different sources of a power plant and, you know, a refinery and this, that, and the other thing. People are in New Orleans, so they've got 100, you know, they've got 100 sources of contamination there. But so you want to narrow, and you want to focus, and in that narrowing process, you want to increase, I think, your quantitativeness, right? Your precision, that you can identify and quantify these things.
Thanks. We have a few other questions, but maybe just to go around and see if anyone wants to add to our first topic. Anything else? Other tools you've used or heard of for measuring oil and gas and water, oil and gas contamination in water, and what metrics they measure?
So I've been investigating the kind of, you know, DIY electronics sensor world of, you know, like what kinds of things we can measure, you know, what kinds of measurements we can take with sensors, and what kinds of ways that these, you know, are related to water quality. And you know, there's a pretty standard list of general water quality measures that are not like chemical specific, like turbidity and pH, total dissolved solids, dissolved oxygen. There's oh, just muted myself, sorry. And one of the big kind of questions that I have been bouncing around and looking into is which of these quantities, which of these measures are relatable to what kinds of contamination? They're all known, like, measurements of water quality, but water quality isn't this kind of single objective line. So I don't know, I'm curious if anyone has any thoughts or knowledge about that. I know that a lot of my understanding is that a lot of what you are measuring when you're measuring these sorts of quantities is collecting baseline data and then looking for changes. If suddenly the dissolved oxygen is really high, maybe someone dumped something. But any more specific information or even just resources to look into, I would love to know or be curious if people have looked into this.
So right before we had this session, I just was like Googling around to see about oil sensors, and of course oil water sensors come up, which I thought was interesting. That was like the first hit. And they were talking about the flotation buoyancy, which I thought was kind of curious because I had never thought of like, is it possible to just have like water, but yet you have something that can define how high up? Like, it's probably not GPS. Like, I don't know how you would get like, what if like something floats higher on a surface? Do you know what I mean?
Other things would affect that as well, like salinity.
Mm-hmm.
Right. Yeah. I mean, dissolved solids in general.
That would be a measure of like specific gravity, and that's that turbidity, these types of things. I mean, that plays into this idea that I was talking about, where you want to focus, right? So you could go out to the various parts of the river or the creek that goes by the fracking sites, and you could test for turbidity and for specific conductivity, these types of things, and find that it's not until you get past this bridge that you start to see the high numbers. And then you go back with a lab sample and you do a test for surfactants or for benzene or for whatever it is that you might think that the fracking fluids or whatever it is maybe coming into that water body. So you use a handheld device that gives you conductivity and turbidity in real time, and you can march yourself down the creek and you find, oh, here's where it jumps up. And then you go in and you spend $100 to get a real sample of that and get some lab data. And I think, to me, that's the way you use your resources wisely, right? Sort of starting with the free and repeatable, that you can get a quantity of data over quality. And then when you narrow down, you get quality data over, when you find that you're in the right spot or you're looking for the right thing.
Katie had a question about surfactants. Do you want me to read that out loud?
Just what are surfactants in the context of water quality monitoring?
Did I say surfactants? I guess, yeah. So
I can't hear you.
Can you hear me now?
Yeah.
Okay. So surfactants. So fracking fluids usually are one of the things that are in fracking fluids are surfactants. So generally they're soaps, but they're soaps that are, soaps might make you feel like, you can put it everywhere. But they're typically endocrine disrupting. A lot of the surfactants used in fracking are endocrine disruptors and possibly carcinogenic. So, but they're soaps, and they're used to change the surface tension of the water and to force the gas out of the shale. So it's various, typically polymeric soaps that are used for fracking, and they do show up in people's drinking water as well as in surface water near fracking.
I had a question maybe that Matei, although maybe also Maggie. Sorry, hi Maggie. Maggie's the baby. Matei maybe knows a bit more about, because I've heard you talk about this a while back, was when oils or oil byproducts get into water, some proportion of it dissolves into the water and becomes part of the water, like completely mixes in. And then some other part of it remains separate as sort of what you would think of as like an oily substance that remains separate from the water, like the sheen on the surface or residues on the bottom. But Tate, not to put you on the spot, but could you talk a little bit about that difference, and like maybe in the context of Newtown Creek, like, you know, explain a little bit about that?
Yeah, sure. I think pretty much described it. So there, you know, when somebody releases oil into the water, so probably like more than half of the product actually mixes with water, and the sheen is just sort of a residue of that. So that's why it is actually very hard to clean the water after an oil spill or something like that.
And in terms of what portions go where, or like what you would find in the water versus in the sheen, is there a sense
yeah, I'm not sure on that. I think that on the water are more the volatile compounds that you know, kind of the almost the fragrance, and mixed with water is everything, all the rest, basically. I'm pretty sure.
Yeah, I mean, not that's that close exactly, but this will sound a little gross, but there's a cooking liquid called liquid smoke, and people sometimes wonder if that's toxic. And there's Harold McGee, does a lot of cooking science writing. He's written liquid smoke is when they burn wood and they capture from the smoke the dissolvable, the soluble parts of the smoke, and not the oily parts of the smoke. And so therefore liquid smoke in theory is supposed to not be that unhealthy for you, even though it is actually just collected smoke. Mm-hmm. It's the less unhealthy portions, although to be honest,
I wouldn't eat that.
I don't know. It's smoke in a liquid form. It's kind of weird. But when you said that, that's what I thought of, is like the separation of those is in something, and that is sort of it gives you the smell of smoke, essentially, or the smell.
Yeah, I think you also get a little bit of the oil, because with the oil testing we were trying to do, like after with the freezing method, so we were able to separate some oil with the from the top of the ice, from the top of the water. But I mean, there exists, you can buy super complicated filters that actually separate water and oil when it is mixed together. I'm not talking about a sheen now, I'm talking about the mixed substance. I don't know. We never tried that because it wasn't super expensive, but it was definitely beyond our budget. But yeah, there is like fairly complex filtration system, how they actually, you know, clean the water afterwards.
Interesting.
Yeah.
So you want me to so if you put gasoline and water together, mm-hmm. You're going to get like oil and vinegar from your Italian dressing, right? You're going to get water on the bottom and gasoline on top. However, you know, if gasoline is made of benzene, toluene, ethylbenzene, and xylene, you're going to get some of all four of those that solubilize in the water phase, right? So you have a column of water that there's a split in it, just like your Italian dressing. But within that water layer, you're going to have some amount of all four of those, just like you're going to have some small amount of olive oil in your water layer as well. And so, you get, if you put a tiny drop of gasoline, it's going to all dissolve into the water. You're not going to get a second phase. And so that's the aqueous phase that's all in there. When you add plenty of gasoline in there, you're going to start to form a second phase, and that's called non-aqueous phase VOCs. And that means you got really high contamination because you've saturated the water with the maximum amount of those chemicals. And now you've got so much in there, you've got a second phase, right? So what the old school for like petroleum refineries and gas stations and everything else is, they would just do basically a visual separation of those two layers. And their environmental controls would be to take that water column and split them like you would, you know, your olive oil off of your vinegar in your Italian dressing, knowing that there's still some amount of gasoline in that water, right?
Right.
It has a ton of,
oh, sorry. Well, something terrible is happening.
like the water can only absorb so much, and then everything else begins piling up on top in a sense. So that's really helpful. Thank you. Katie, did you want to go again?
Yeah, so like in that example, among those 4 compounds, like, is there enough, I'm thinking about like going back to Leslie's point, thinking about like density columns, where there's this like kind of very straightforward like visual that you use in like educational work, where you like layer different materials of different densities and then drop things in them to see like where they float. So thinking about the example of gasoline, like, is there enough differentiation among those four compounds, like in that example, just kind of hypothetically, where you could like do like where you could get that kind of differentiation?
Right. And yeah, I mean, I think the answer is no. Like, they do make like they make specific gravity things. Like, I don't know, you know, it looks like a fishing bobber, right? So that are tuned to a very specific gravity, and you can put it in, you know, if you had water and if you had oil, and it will sink a certain amount, and you can get a reading for how dense the liquid is, right? But the difference between water that's pure water and water that's got saturated with benzene and ethylbenzene, toluene, and xylene is going to be so small of a difference that this crude, you know, drop the bobber in and see how it floats is not. I can't imagine that's going to tell you much of anything. I think I remember doing in some chemistry lab like those very basic tests, like on, you know, day 1 of some lab. But the difference is really like between olive oil and water, not water with a tiny amount of something in it versus a tiny amount of something else, right? Unfortunately, that's just not gonna identify a difference.
I wonder, going back to that question that you, oh no, oh baby. The question Will had then about like what's best to go for maybe first. I'm wondering if it maybe is it conductivity.
I mean, conductivity is a good one because you can get a cheap meter. It will tell you something about the water. I mean, and basically it's telling you if there are salts in the water, right? So, you know, if there are things that are dissolved in there that are ionic, and that's helpful. It's not going to tell you everything, but again, you know, it's like the classic story that you hear in communities, and, you know, it seems like we have public lab people and community members. You know, somebody will call me and say, well, we tested our water and it was fine. Well, testing your water only is as fine as what you tested for, right? So you can test it for bacteria and conductivity and not see anything, but it doesn't mean that you don't have benzene in it. But if you're looking for something near a fracking site, you know, that's conductivity might tell you something, right? It's not going to tell you everything, but it might tell you, again, like, you know, past this bridge is where things heat up, and let's focus our investigation there, and let's, you know, look for trucks that are pulling up to that bridge versus the other bridges, or whatever it is that you're trying to figure out. So conductivity is a good one. pH is a good one. You know, you can get a pH meter cheap. I have a fluoride detector that I use, which I won't get into fluoride right now, but like, you know, I've done testing of various teas for fluoride because teas contain high fluoride. And in fact, if you drink a lot of tea, you can be overdosed with fluoride by just from your tea. So there are those, you know, $50 to $150 instruments that will give you a real-time continuous readout of data that could be very useful. And conductivity would be one, pH would be another, something like fluoride or some ionic detector could be as well.
I was thinking, you and I were going to co-moderate here. Did you want to jump in with the other questions or sort of guide the conversation?
Well, one thought that's coming up for me related to all of this would maybe be, I'm thinking about, well, I think the comment about health kind of maybe brought up this framework for me, but I'm thinking about how in the healthcare field, you'll have screening tests and, right, I think in a lot of ways what we're talking about is this a similar thing, but environmental screening tests. And so one way to think about these things would maybe be like what screening tests, we would start out with our least expensive screening tests and then maybe thinking about what tools are the most effective in terms of giving us, you know, like avoiding what, you know, what gives us a false positive or a false negative, or, you know, what information are we getting? So I just think it's interesting that maybe like a change in conductivity would be a, you know, a potential positive. I don't know, just thinking about that framework. I think it'd be interesting to follow up on this and parse out where our different tools fit in terms of when they're going to be effective for giving us that sort of further information. Yeah. I don't know is everyone kind of done with talking about tools, or are there any other things we haven't talked about yet? Yeah. For sure.
Leslie?
Yeah, sorry, the mute is like not reacting well today. So I think I just wanted to go back to the Google Earth engine, not to be mistaken for normal Google Earth, but Google Earth engine allows you to get into all the satellite data and literally customize maps. So like I am already interested about whether like say Copernicus has an aerosol index that it gathers. There's not a whole lot of sensors on satellites doing air quality stuff, but I'm certainly curious about that with the naphthalene or whatever. And if that's not helpful, Kate, I would be curious if those plants have something that LiDAR or something else could look at the structure of the plant so that there, you know, is there something mechanical about a plant that we would know when there is a release, even though we can't get the gas from the release, if that makes sense. So I'm very interested in how remote sensing can be helpful. And certainly with SkyTruth, we know they're looking at oil from above like all the time. So anyway, I'm finding it to be a really cool citizen science tool that anyone who knows anything about coding probably can start playing with.
Maybe another interesting one that you bring that up could be heat related.
Yeah, there was this old thermal fishing project where, and you know, different variations on that where people were trying to use like the temperature of water to identify an inflow to a river. So, you know, you sort of assume that the inflow could be a different temperature than the main river, and that would show up on a thermal image. So there's some interesting possibilities there. And the SkyTruth has done a bunch of different types of observations, but one that they promoted a couple years ago was making images of flaring, I think, right? That was kind of an interesting one. So they took nighttime photography of the entire United States. But yeah.
Well, one of the things, I mean, you brought up LiDAR. I mean, there are studies of using LiDAR to quantify pollution emissions. I've never done it. I know that they're published, and there are people that have proposed, researchers that have proposed using that for permit assessments, like to see if they're within permit limits. So there is a way to use that, whether any of that data is the type that's publicly available or through Google or whatever. But LiDAR is something that can be used to do remote sensing. There's also FLIR cameras, which you guys have probably had some discussion of FLIR cameras. Again, the FLIR camera is a $20,000 device, but you can rent them, and you can then, it's a camera that you look through, not unlike your temperature sensing FLIR cameras, but a much more expensive one that can sense VOC emissions and chemical emissions from a facility. So if you're looking, one of the things I've been looking at, WebMD folks have been talking to me about some of the ethylene oxide plants, these sterigenics and these medical sterilization facilities, and they release a ton of ethylene oxide, and no one's really paid attention to them, and it's pretty significantly carcinogenic. And so we're trying to figure out if a FLIR camera could be used to just, to film these facilities, which are in, I think, pretty nondescript office buildings, but they've got a couple of vents on the roof and they're farting out a bunch of stuff, at least presumably. And would that be a way to identify their emissions, which it at least potentially would be.
I just want to note that we're coming towards the top of the hour and don't want to hold anyone past what you can commit to here in open hour, but happy to keep the line open for anybody who wants to continue on. But it's not rude to jump off whenever, so just to say that. In that conversation with some of the more expensive ones, one of the things I'm thinking about is, Will, you've been posting a good bit lately on some new tools, one specifically related to turbidity. Can you describe a little bit about what you're going for with it?
Yeah, so I have been looking at a set of liquid water quality sensors that are designed for the Arduino. They're made by a company called DF Robot that does a lot of kind of hobbyist electronics stuff. And they have a whole kind of set of sensors for different water quality measurements. Most of the ones that I just listed, turbidity, pH, dissolved solids, conductivity, things like that. And I have been working a lot with the turbidity sensor just because it is the cheapest of the set, and so it seems like a really good sensor to just kind of start playing around with and trying to get into people's hands in the absence of a compelling reason to pick any other metric. But what I have been kind of focused on is just trying to get a project where that makes it easy for people to use these sensors to to go out and just collect some quantitative data, and then trying to think about what can be done with that quantitative data if it's easy to get, and under what circumstances it is worthwhile to deploy people with these sensors for people to go and look at things, and also thinking about how to take and they're relatively cheap hobbyist sensors, so they're probably either require some kind of calibration. They're sensitive to different things at different times. They're not necessarily measuring exactly what we want. So also wanting to do some experimentation to play around with what the limitations of the hobbyist sensors are. That's been that project, which I have posted a couple research notes about, and I'm gonna continue to kind of push on and try to get some of these sensors out to people to play around with.
Thanks, Will. Does anybody else have other things to share or add on this? We hadn't talked about that one, and I wanted to put it out there because it seems almost like it's on that spectrum of cost potentially, and lowering that barrier a little bit for that one.
There was this question in our brainstorming notes here on how to represent data collected, and I've been sort of noodling on this idea after reading about how the red cabbage could be used to dye paper. One thing I was always inspired by, I think I mentioned this on past open hours, is there's a project to track hydrogen sulfide that people posted on Public Lab a long time ago, and they took little paper strips that were prepared that darken in the presence of hydrogen sulfide, and And then, but the cool thing I thought was how they presented, they had a map of the site and they actually glued each strip where it was taken on the map. And so they made a map that was sort of had a gradient of little squares that were darker or lighter. And you could really sort of see where they all, you know, were sampled from. And it made me wonder, like, I don't know, I want to try it, and I don't know if cabbage is enough range of pH or if pH is even that interesting, but of basically making a map and then dipping the whole map in this cabbage juice, and then using an eyedropper to put just one drop of water from a river on the place where it was eye dropped out of, I guess, and to literally just use the map as the strip to see if there's changes in that. And I mean, maybe pH is not that interesting. So if there's some other vegetable that in juice that gives you a different metric, please tell me.
No, it's
but I
cabbage.
wanted to start with that because I think the space. Sorry.
It's cabbage.
It's
I mean,
but
for
it's
a
not
different.
stable. Like you'll
Yeah.
start losing color in 24 hours.
Yeah.
The
For a different metric than pH is sort of what
Do you know, guys, what compound in the cabbage actually does that?
I think it's anthocyanin. It's that reddish, you know, sometimes you'll see trees. Anyway, but the main thing is just the spatializing of that data and the presentation of the data in a way that maps onto a place and proximity. You could also do one which is a timeline, like, you know, line up like a huge ton of like pH strips or something, and then you get into this question: does it last long enough? You know, does it wear out? And then you can't do a time series. But stuff like that, I think, is really a compelling way to present the stuff, even if you are writing down the hard numbers and doing a different kind of calculation later.
There's a there's a pigment that is also a pH indicator. I think it's goldenrod yellow, but you could get that color and paint the rivers with that before putting it on.
I was just thinking the same thing. Like if you just use the regular turbidity strips and then have the color of, you know, 7, the color of the river.
Well, you mean like if you buy goldenrod watercolors or something?
Yeah, there's some paint that happens to be a pH indicator. I don't remember. It's origami paper yellow, but I don't remember what it is.
Thanks for humoring my digression.
Does anyone have anything else to chat on this topic or another related?
Sorry, one more thing. So I think I just wanted to hear from Louisiana point of view. What is your real question at this point that you're trying to work on?
Yeah, I think Roland is a little more community connected through another nonprofit he works for than I am, but we're definitely seeing a period of time in Louisiana right now where there's a lot of environmental justice happening, a lot around petrochemical plants. So the people trying to block Formosa and looking at a lot of health impacts because of that. I know most of that has been more in the air quality kind of world. Yeah, I think, I don't know if Roland wants to speak more to that, but.
Well, I think my biggest thing was to of course do the testing and inform the community of what was going on, but I also, I think like the biggest question that I get is, what do you do once you found out that there's an issue? You can inform, the companies, but what do you do to your home as far as, I can tell them, as far as air quality, I can tell them about dehumidifiers, changing filters, but there's always going to be those questions like, what else is there as far as, do I filter my water more? Like, what else? Like, my biggest thing is what are the methods that these communities should take or members should take as far as purifying the water and doing? Do you have, you guys have any ideas?
Another way to think about that question could also be, what could you measure before and after taking an action to see whether it had helped, right? Like measuring something before you filter and after you filter. And so if there are particular easy to find measures, the danger there is that you don't want to be telling people, oh, there's low turbidity, so your water's fine to drink or anything like that. But there might be some value in for instance, we have lead in our water here in Providence, and so we installed a filter, and we did some lead testing before and after we installed the filter to see whether the filter worked. It seems to have. Who knows? The filter was a color that was slightly different from the other color, so it's all a little dubious. But my point is that we really did. We wanted to install this filter, but we also really wanted to do a test to see if it was helping, for the thing that we were worried about. And so I wonder if there is anything that people can measure to check for those things, if people are worried about like the things around tap water and not just river water and things like that.
I'm wondering, Chris, do you have any for Roland's question or like issue around the next steps? I'm wondering about your like advocacy ramp that you might suggest or think on.
Yeah, I mean, it's probably a question that should have its own entire hour.
We should do that. Yeah.
Filters, and the point that I forget names, I think Will just made. I mean, some of these things, again, I was using the example of the stream, but if you are testing your tap water, so for example, I mean, I know folks that lived in Pennsylvania and they had fracking near them, and after the fracking started, so usually you find out, oh, somebody got a permit, the drill rig shows up, you can do some testing of your water, again, the basic testing, strips, cheap device, whatever, and get some baseline data, and then they start fracking, they start drilling, you notice changes that you perceive, but also you can get some of this data, get the before and after to give you some ability to say, look, my water quality has changed. It's not the explanation for why you got cancer 20 years later, but it's an explanation, or it's a demonstration of the fact that something they're doing has affected your water quality. So, and air filters, I mean, a simple example that is not necessarily because of the refinery, but mold, right? I mean, people live with mold all the time, and it's ubiquitous, but it can be dangerous, and having an air filtration system in your home, at least in your, primary, like your bedroom and things, can be a way, whether it's mold, whether it's particulate matter, some of these other things that a good air filtration system can take care of. So if you were, if you're living near that refinery, in Plaquemine, Louisiana, there's probably tons of particulate matter in the air, and something like that would be useful. Now, the problem that we all know with the people living in that part of the country is they can't afford a $600 air filter. So, it's classic, call it environmental justice, call it racism, call it, economic ism. It's, the problem is the tools that people could use, like a whole house filter for their water with reverse osmosis, is going to cost them $1,500. That's the kind of thing that people can't afford when they're being dumped on. So it's yeah,
I would totally agree. And I would add too that because there's really like prolific environmental degradation, it's something people don't think they have any control over, I think. And so I think it's just, I think there's like a first tier that's even getting people to pay attention and realize that this is something that they might actually be able to impact, and that is really impacting them. And as you said, making that accessible. And then hopefully narrowing down on kind of which of these challenges has the most acute impact, and how to advocate.
it's kind of cool because what you're both saying leads me to believe that there's a need even for the not so technical kit of you always need to test like as soon as you move in or move period, you need to test, or maybe everyone should be testing a certain amount no matter if they've been living in the same place to see change. Like it's almost like just like people are walking around with Fitbits nowadays, like we're so busy looking at ourselves that we're missing the biggest things that will kill us. You know what I mean? So it's like, what if there was a kit that just spelled out these very simple things you can do? I'm almost thinking of the kits at Home Depot, like, send it in the mail, get it tested. It's less than $25. I mean, I know that can be a lot for someone too, but I could see the public lab version being even friendlier as far as spelling out, here are the top things you can do to improve your health and knowledge.
Yeah.
Well, I mean, you can, sorry, not to, I know I keep saying I'll shut up. I mean, you can get, I mean, I have an Eve sensor in my house. I mean, fortunately for me, like I don't live near a refinery or a gas station but I have an Eve sensor. You can get, I have an Atmo tube somewhere, which was one of the first handheld VOC, smartphone detectors. Now there's probably tons of them, but those kind of things, I mean, they're probably anywhere from $50 to $150. And like, that's the kind of thing that if you live near a refinery and you tested your air, you're going to see changes. I mean, you smell them. Now you've got another piece of data that doesn't just rely on your sense of smell, which anybody and everybody is going to dismiss. They're going to dismiss a $50 detector too, but like it's, it starts to build to a point where, it's not just you and your sensitive nose, you're getting some data, and it's actually with these devices now, like you said, I mean, they're being logged, 24 hours, which is helpful. And, it's true. Like we've spent how much money developing more accurate sensors for how many steps you've walked. But the truth is the thing that is potentially killing entire communities is not being tracked. That data is not available.
And I was just thinking too, Leslie, with what you just said, it's so interesting when you buy a house, you have to know, like the bank will make you know whether you have lead paint and whether you have radon coming in your house. And they're easy things that you do before you buy the house to tell you that. But we don't do the same thing for the environment that we live in.
Yeah, I'm going to add one thing because it's something that the people in the group might have an interest in. I think this is a really important point when people get diagnosed with cancer, particularly kids, because their environment, their cumulative environment is very small. I mean, if you're 4 years old and you're diagnosed with cancer, you didn't work in a paint plant, you didn't work in a chemical plant, you didn't drive a diesel truck for years. So your environmental footprint or exposure footprint is tiny. And when kids get diagnosed with cancer, to me, to the point that you just made, is why are insurance companies and doctors, they're spending $300,000 or $3 million on chemotherapy for that kid. Why are they not testing their home environment? Why are they not testing their water and their air to find out if there's something there, not only that caused it, but when they get that kid into remission and they send him back home, he or his brother or sister that's there is being exposed to the same thing, right? So to me, those are, and that's actually a place, no offense to public lab, where a couple $100 is small potatoes compared to what we're spending to try and deal with this problem. And it's like, what do you mean,
Yeah. It's part of it too, is just who the burden falls on. Like it's ridiculous that the burden for all these falls on the victim.
Right.
One of the things that I have, that I've found is that even if you use like a simple, Atmo tube, just in the area that I'm in, that I work in, just different within a mile, it can be totally different. You can have, it can be solid on, the air quality can be totally different on each side, and it's kind of hard to, and it seems like it varies throughout the weeks or the months. It changes slightly, and I guess because it's in between chemical plants, you have it's almost like a peninsula, so it's kind of 3/4 of the way surrounded by water. So it's kind of in a situation to where you have ships and tugboats traveling on one side, and I think the neighborhood is, they might see where, you know, in January where, you know, the air quality is in, you know, at whatever grade or low as far as pollutants, but then, you know, toward the end of the year, it's kind of different. So I think that's the other thing that we kind of have the issue with. So I was just wondering what, you know, is it a thing to where is it safe throughout, or do you think that it's more safe to tell people that, you know, these things vary, or you tell them that, hey, you should be on full alert at all times?
I think that's a really hard question.
Yeah, absolutely.
Well, and there are other things that come into play, and we could go down a deep rabbit hole on this, but like,
yeah,
a lot of times what people will end up talking about, like things come into play, like house values, right? Like, do you ethically, like, exposing those things, or being or like the ability to get out of a situation?
Yeah.
That's the story of my life. I mean, going into a community, I mean, a woman's texting me right now from a community that's got contamination from the local landfill, and it's coming up vapor intrusion into their homes, 400 houses. And, you know, as soon as they test, they've got to disclose. As soon as they disclose, their property's impacted. But, you know, what do you do? And when you have a community of 400 homeowners, they don't all have the same response. You know, and unfortunately, I can't promise them that I'm going to have a successful lawsuit. All I can do is say, you know, here's what I recommend, and it's, you know, there's no good answer.
I've been thinking we should have a special series just called Real Estate versus Reality. Just play that out.
Yeah, I mean, it's like you're talking also about like kind of like points of entry, like thinking about like I was thinking about when we moved to Providence, the kind of like one of the Roland is, I'm sorry, I don't know if I caught your name exactly, but like I think one of the things that is also challenging about figuring out how to do like correct notification is that it's hard to pinpoint sources with specificity, but it's also hard to like control how people hear information, or how people, like a lot of times, and I don't know if you have in your community like a kind of like consistent way to get information out to people, but I know it, like in terms of like when we made pretty specific choices about where we were going to try to live, that when we moved to Providence, which has really kind of terrible environmental contamination in a lot of different areas, but specifically around highways, and our decisions were those decisions were based on like the kind of totally random fact that like we had proximity to some studies that were done about highway particulate matter that like scared the shit out of me. And I had once at a meeting seen some graphs of like how close you could be to a highway. And that had like a real impact on us, because when we were looking for places to live, we were like, okay, well, we're not going to be within 500 feet of a highway, like at all. But that's like a pretty random like set of like inputs for that kind of decision making. Whereas like, you know, so like Leslie was talking about, like something like when people change context, like when people buy a house, or when people sign a lease agreement, or when people like register for trash pickup or whatever, like those are actually really kind of powerful input points for communicating information. And that's like if I, yeah, I mean, I think somebody might have said this, like if I could like go to Home Depot and like pick up the checklist of things that I'm supposed to be looking for, that's actually a pretty low, and Public Lab could put together a version of that and could, you know, release it, kind of, you know, just internally and to like connected communities. But that's a pretty low barrier entry thing to also like pitch to like higher profile organizations that Public Lab is working with. I don't know what exactly I'm saying, but like being able to get a checklist is better than the like accumulated knowledge of going to some random meetings where you pick up information that like may or may not stick with you.
I love that idea.
And the checklist is in a lot of ways like easier to put together and disseminate if it's like kind of tagged to moments when people are in transition. But thinking about like buying or renting, or renting less, because that's completely like non-systematized. I guess buying is too, but anyway, those are just kind of random thoughts.
Sorry, I'm muted my volume.
You're running.
I would also add that I think it's just sort of unfortunate too, because then it turns into something where like the people who aren't getting that information, or the people who don't have more money to afford to like live in the better places, are still losing out somehow, which is why I think like the advocacy aspect is so important in addition to the educational aspect.
I think we should plan another open hour on some of these topics that have come up tonight that are related.
Yeah, and I actually have I have a guide from the Tulane Environmental Law organization put out an environmental advocacy guide. So I'll share the link to that on Public Lab, just so that folks can look at that. But it does a pretty good job of laying out a few different paths to advocacy. And it'd be interesting to hear more about personal stories too. Is there anything else folks wanted to talk about?
I think we're good. We've definitely gone over, but it's been a really interesting one. And thanks everybody so much for joining. And we have a lot of notes. And I think like this was very helpful for synthesizing and learning new things.
Yeah, definitely. Thank you everyone so much.
All right, well, I think we're all in evening time zones. So everybody have a good evening.
Bye.
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 Bye.